Hi and good day. My name is NURFATIN ATHIRAH BINTI ABDUL HARITH from UiTM Perlis. For my final year project is about removal of organic sulfur from coal by using peroxyacetic. This is my presentation outline. Introduction. For the background of study, coal desulfurization is important for producing clean coal and minimize hazardous pollutant to burning. However, organic sulfur in coal is more difficult to remove than inorganic sulfur. Therefore, in this paper, a method of coal sample desulfurization using peroxyacetic acid with ultrasonic assistance was proposed. The effect of consideration of PPA, temperature and time on desulfurization was studied on value determined by using response surface methodology RSM. The coal was obtained for Jambi processing, Indonesia. The effect of sulfur in coal is when the coal is burned, sulfur released as sulfur dioxide, which is toxic and corrosive. This sulfur dioxide, when combined with water vapor, it performs as sulfuric acid. This sulfuric acid combined with rainwater and fall out as acid rain, and will disturb the ozone layer and destroy the ecological system. For the significance of study, the significance of desulfurization of coal is to generate manufacturing that can produce a clean emission depending on the state of the sulfur removal. The second one is the community can be educated early on about the danger of sulfur dioxide, both health issue and environmental issue. The third one is it can give a guideline for future research to utilize this method for investigation, analysis, and could attract the global attention to avoid hazardous sulfur emission during a coal utilization process. So for the objective of study is to treat coal with peroxyacetic acid using ultrasonic assisted extraction system. The second one is to determine the effect of concentration of peroxyacetic acid, temperature, and time on organic sulfur. The third one is to characterize the desulfurization coal by using elemental analyzer and sulfur assay. For the scope and limitation, under moderate condition, organic sulfur could be selectively oxidized and removed by peroxyacetic acid, which is PPA. The challenge in this study are desulfurization effect of PPA alone was not ideal and optimal as its desulfurization was too long. As a result, PPA is combined with ultrasonic assistance. This can greatly increase the significance and improve the organic sulfur removal. This work will focus on organic sulfur removal from coal by treating the coal with PPA using ultrasonic assistant extraction system. Literature review. Sulfur content in coal is referred as coal that have less sedimentary road that contain carbon, hydrogen, oxygen, nitrogen, and sulfur as shown in figure 1. Sulfur in coal is found in two forms, which is inorganic sulfur and organic sulfur. Organic sulfur is generally sulfur that containing functional group combined with organic matter. Organic sulfur in coal is generally in coal micromolecule skeleton, and its chemical structure and composition are very complex. What is peroxyacetic acid, which is known as PPA? PPA is actually organic compound used in chemical cleaning method for coal desulfurization. The property of this PPA are high oxidation potential, which have relative high reactive oxygen content. Therefore, acetic acid with hydrogen peroxide reaction is preferred in common preparation of PPA. This is due to the reaction reversibility and thus equilibrium mixture of reactant and product is obtained. Research in the impact of microwave radiation with PPA desulfurization of sulfur content revealed that the overall sulfur reduction obtained after chemical desulfurization with PPA is between 49% to 58%. Besides that, another research by the Ishaq et al. 2016 in chemical desulfurization of Indonesia sub-bituminous coal with PPA reported that the total sulfur, including both organic and inorganic sulfur, decreased from 3.56% to 1.29% by weight. Ultrasonic coal desulfurization is a permanent method for removing sulfur from the surface and inside the coal. The acoustic cavitation effect occurred during the ultrasonication of coal is essential for this disintegration of water molecule into free radical and producing the highly reactive species of the strong oxidizing nature as shown in the figure 3. Ultrasonic process enhance the surface area of coal particle and offer enough anti-side for chemical oxidation. The next one is methodology. The chemical used is acetic acid, hydrogen peroxide, nitric acid, barium chloride, and hydrochloric acid. This is a framework on how to desulfurization organic sulfur. The first procedure is desulfurization using PPA. The second procedure is sulfate sulfur determination. The third procedure is pretty sulfur determination. The fourth procedure is total sulfur, which is using elemental analyzer instrument. The last procedure is organic sulfur determination, which is the percentage of organic sulfur was obtained by subtracting the sum of percentage of total sulfur, percentage of sulfate sulfur, and the percentage of pretty sulfur determination. Center composite design under response surface methodology RSM in design aspect version were used to optimize the 90 set experimental factor. The experiment factor that were optimized in this study are concentration percentage, temperature, and time in minute. The three experimental parameters A, B, and C and response output of organic sample were fitted together in quadratic polynomial model. Parameter A to C are numeric factor which that mentioned in table 1. Result and discussion. Table 2 show the experimental agreement of RSM for desulfurization and the percentage product of result. The percentage organic sulfur removal is calculated as shown in equation below. The relationship between the actual value of factor A, B, and C and the response of organic sulfur removal by PPA were developed using RSM. ANOVA analysis were used to evaluate the epidemic quadratic model, which is the best model fit with the experimental data. The 90 experimental run generated by RSM with the various estimated parameter along with the experimental and predicted value of organic sulfur removal as shown in the table 3. 1. Figure 4 show the predicted versus actual value of percentage of organic sulfur by PPA, which is show they are in good agreement. The regression equation for the desulfurization of organic sulfur by PPA in the term of coded process parameter as shown in equation 3 below. The coded equation is useful for identifying the relative impact of organic sulfur by comparing the factor coefficient. The experimental finding, the removal of organic sulfur by PPA have significant influence in the concentration of PPA extraction process. Based on ANOVA analysis in table 4, S squared seems to be the most influent process parameter on desulfurization production indicated by the larger value of F value. Since the factor S squared was the larger value of F value among all the value for the significant factor, therefore concentration of PPA is the one of the main parameter during desulfurization process. Interestingly, the result that shown in graph 1 on the effect PPA concentration include desulfurization by a mixture ratio of 30-70 acetic acid hydroperoxide, it shows the stability in the value of organic sulfur reduction between 48.36% and 59.27%. In addition, concentration of 20-18 acetic acid hydroperoxide will show the significant impact on the desulfurization rate at 53.36% of organic sulfur removal. This confirmed by the research done at 2018 that stated that the higher in hydrogen peroxide concentration resulted the capable in removal the organic sulfur content include from 1.58% to 1.36% by weight in organic sulfur. Hence, this finding show that the increase in concentration ratio of hydrogen peroxide from 20 to 30 has significantly improved the removal rate of organic sulfur removal. For the effect of temperature in organic sulfur removal, graph 2 show the higher removal efficiency on organic sulfur was 60.51% at 30 degrees Celsius, while the range of removal organic sulfur in low efficiency was at between temperature 70 degrees Celsius and 80 degrees Celsius. Literature on Zen et al. 2018 confirmed that the organic sulfur by the boiling of the cool solid which can produce bubble which might deteriorate the chemical reaction between PPA and cool sample. Therefore, the result obtained at range temperature at between 70 degrees Celsius and 80 degrees Celsius is started to just to increase due to the temperature is nearly to the boiling point. Moreover, desulfurization reaction at elevated temperature of 70 degrees Celsius might also has resulted to insufficient time for the PPA to diffuse into the cool microstructure. For the effect of time on organic sulfur removal, based on figure 3, show that the removal of organic sulfur as function of sonification time, it was confirmed that ultrasonication can improve the chemical desulfurization effect of PPA in certain time range. The removal rate of organic sulfur reached their maximum of 60.41% at 30 minutes. This means that the sonification process has a different impact on chemical desulfurization process by PPA. According to the measure at 2050, the increasing in time made the PPA able to produce the hydroxy cation, which are the strong electrophile and react with sulfur atom because they are causing more nucleophile than carbon atom. The interaction of process parameter was studied using ANOVA analysis indicate that the optimized operating condition of process parameter of concentration, temperature, and time are 70 at 70, 30 at 30 degrees C and 30 minutes respectively. This parameter show that resulting in 39.19% of actual organic sulfur removal and 38.19% for predicted organic sulfur with the significant standard deviation of 0.39. This parameter show that the slightly closer resulted as the one predicted by RSM, 38.90%. The difference between the predicted and actual resulting have the end error 0.39%, which is allowable. This implies that the model was correct and the solution generated was optimal. Conclusion and recommendation. As a conclusion, peroxyacetic acetic was significantly able to remove organic sulfur from coal. The process was successfully modeled and optimized using design expert sulfur with RSM technique. In this study, the organic sulfur removal after chemical desulfurization by PPA with ultrasonic are achieved in the range of 32.67% until 60.41%. The results show that the organic sulfur were manually attacked by PPA after solidification depending on the concentration of PPA, temperature, and time. As a recommendation, the use of BPA as a mild oxidative agent for cool desulfurization has been reported by many authors. The second one is BPA is able to produce hydroxy cation which are strong electrophile and react with sulfur atom because they are considered more nucleophile than carbon atom. The third one is require low temperature. Cool with BPA pretty much have positive effect on enhancing organic sulfur reduction as it requires range temperature between 30 degrees C to 70 degrees C. It is because increases temperature further decreases sulfur removal. The third one is ultrasonic have showing the positive effect on cool desulfurization with BPA which may link over 30% of organic sulfur is successfully removal. This sulfur removal can provide safe and environmentally sustainable coal for combustion, on which also key for aspect agenda of 2080 for sustainable development. This and high quality of coal will reduce the health impact on population and benefit the economy, and it also possible to optimize the use of coal for energy production and manufacturing. This significance of coal sulfur removal can generate the manufacturing the use of coal to produce a clean emission of coal and can educate the community about the danger of sulfur dioxide. That's all. Thank you.